Grace Hopper is now in full production. Nearly 200 billion transistors in this computer. This is the world's first accelerated processor, accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer's on here. It uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. 4 petaflops transformer engine, 72 CPU cores. They're connected together by a high-speed chip-to-chip link, 900 gigabytes per second. And so the local memory, 96 gigabytes of HBM3 memory, is augmented by LPDDR memory across this link, across a very, very large and high-speed cache. So this computer is like none other the world's ever seen. Deep learning recommender systems, this is how we get news and music and all the text that you see on your devices. Recommend, of course, music and goods and all kinds of things. Recommender system is the engine of the digital economy. This is probably the single most valuable piece of software that any of the companies in the world runs. This is the world's first AI factory. Grace Hopper has more memory on this one module than all of these. Does that make sense? And so as a result, this is so easy to use. Plug this into your data center, and you can scale out AI. Okay? So this is the reason why we built Grace Hopper. So let me show you what we're going to do. So the first thing is, of course, we have the Grace Hopper Superchip. Put that into a computer. The second thing that we're going to do is we're going to connect 8 of these together using NVLink. This is an NVLink switch. So 8 of this connect into 3 switch trays into 8 Grace Hopper pod. These 8 Grace Hopper pods, each one of the Grace Hoppers are connected to the other Grace Hopper at 900 gigabytes per second. And then we connect 32 of them together with another layer of switches in order to build this. 256 Grace Hopper superchips connected into 1 exaflops. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected. Why don't we take a look at what it really looks like? This is our brand new Grace Hopper AI supercomputer. It is 1 giant GPU, utterly incredible. We're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access. And they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. So this is the DGX GH200. It is 1 giant GPU. All of the reasons we all know well, video calls is now one of the most important things we do. Everybody does it. About 65% of the internet's traffic is now video. And yet, the way it's done is fundamentally still the same. Compress it on the device, stream it, and decompress it on the other end. Nothing changed in 60 years. The question is, what would happen if we applied generative AI to that? We have now created a computer. I showed you, Grace Hopper. It can be deployed broadly all over the world, easily. And as a result, every data center, every server will have generative AI capability.